you recently had a collaboration with Google on research, and in it, you tackled the limitations that modern databases face with the static nature of components like index structures, filtering methods, and partitioning schemes. So, can you explain what these problems are and how they can be improved with machine learning?
Yes, certainly. The original work was like this was an idea which came at some point, like while I was at Google. So I was doing a sabbatical there. So I took a leave from Brown University back in the day, and spent a year in at Google in a team which had nothing to do with systems, databases, or normally what I would have been doing. So there, I was like with Ed Shee, and he runs their he runs a big research team around recommendation engines. And so everything I was hearing was like all this stuff about neural nets, and it was a complete different world. And so, while I was there, at some point I had this idea of that we can potentially change entirely the way on how we find data. So to give you a more like tangible use case here, it's just like, let's assume you go to the library. Like if you want to find a book by a title, what you can do is go to the catalog and then find the right index card which tells you where the book is, right? So like normally every library has like a bunch of these like drawers, like the whole catalog, which is like alphabetically ordered, which helps you then with your title in mind. Let's say Harry Potter, you first have to go to the drawer with age, and then you find the right index card that points you then to the location, right? And this is essentially on how every single database system right now implements the way to look up data. At least if you support something which is called range squares. There are some other index structures, but this is like this way of like traversing a catalog is like one of the key access methods every single database has. However, if you go to the library, you probably wouldn't go to the catalog first. The first thing you would do is ask the librarian and say like, I'm looking for the Harry Potter book. Can you tell me where it is? And he would roughly point you in the right direction.
Right.
He wouldn't tell you exactly where it is, but he probably will say something like, oh, look into the right corner. And there are all the kids and young adult books. And then I think it's somewhere on the right, left, in the middle, right? So like this is normally what librarian would do. And so what I was wondering myself is just like, can we not do the same thing for a database system? And so instead of having this like catalog structure, which is like you have to build and maintain, and it's very expensive, replace it with a model which is approximate, and then do some localized search in the end, which guarantees that you find the same data. And it turns out that like if you do it the right way, this can be actually much, much faster. And then it turns out that you can use the same idea also to replace other data structures. So not only B trees, which is the typical way of implementing this catalog, but you can potentially also do like Bloom filters with that. Right? You can use the same idea to improve sorting. And there are a bunch of other things. And the core principle behind them is all the same. It's always that you learn a model over the data, normally the data distribution, and then you leverage that model to design a better algorithm that is more efficient. So that's one category. And then it turns out that you can actually expand that even further when you take like other things like the workload into consideration. And so this is now then called like algorithms with oracles, right? So like you take an oracle, a model as a prediction, and now you design a better algorithm with this model in mind. And this is, for example, useful for scheduling or for query optimization. And there are a bunch of other algorithms or components of a database system as well, which you can like integrate these models very, very deeply within. Overall, like the end result eventually will be what we call now an instance optimized system. So if you take a traditional system, it's like an architect designs it for a range of potential use cases and workloads and data. And as a result, it works for a whole range of applications, but it probably doesn't provide you the best possible performance for each one of them because of this general nature. right? But now if we have this like mechanism of machine learning and it's deeply embedded in the system, we hopefully, or this is what we are working on, can build something which we call an instance optimized system. So the system is self-adjusting all its components based on the workload and the data it observes to provide unprecedented performance, like orders of magnitude faster. And we are heavily working on that. We actually have a prototype, and it's very, very promising.
Super cool. So I guess the main impact of these kinds of techniques like learned Bloom filters or learned indices, which allow databases to be more efficient by learning particular characteristics of the particular data that are in them. I guess the main impact is that it makes using databases faster for practitioners, right? Are there other benefits as well, or is that the main thing?
It's faster and easier. So like it's a traditional system normally has a bunch of knobs. So like if I design, let's say a database or a key value store, like pick your favorite system. Normally I not only make a bunch of decisions about the workloads I expect to arrive for the system, and I design the system in the way for these workloads I have in mind. But often, like I also put a bunch of knobs in there because I know I need to tune certain parameters in the right way. So now if you go to instance optimized systems, like the hope is that we can not only configure the entire systems in ways which are not possible before, but also that we take the burden away of tuning all these knobs for the end user or the administrator. Right? And so as an end result, it's easier to use because you don't have to tune the knobs anymore. Plus, you potentially get way better performance, like orders of magnitude faster than what's currently possible.